Hi everyone, this recording is related with our week 6, so it's makeup class as you know, and if you want to see this week's class note, here is the week 6 class note was uploaded at this class notes tab. You may download and read this document on your own. Today I will explain this class note to you. Before the week 7, actually I advise you, you should watch this record before this 7th week. And let's start this week's content. So as you see, and here we will start to see this week's chapter. So its chapter is related is decision structures and usage in algorithms. And we saw some numerical systems. We saw, for example, BCD, and at the last time of our classes, we saw what is Unicode, what is EPIDIC, what is ASCII code structure. Now we are all clear about these number systems and why we actually see these chapters, why we need to understand these numerical systems, and you are responsible about these number systems for your first midterm, and at your second midterm, at your final exam, you will be responsible about number systems. And actually, generally, you will create some flowcharts. You will create some solutions by creating some algorithms for a specific problem. In these exams, I'm planning to give you some specific problems to solve by creating these algorithms and flowcharts. In most of these problems, actually, you will add some decisional structures to these problems. And we will see how can we add these decision structures. So as you see, we are done about this weeks, as you know. Now we will see in this part. In programming, we often want to check a conditional statement and then do something if the condition is met, and do something else if the condition is not met. This is done using the if conditions. So we are generally calling the structures as if-else structure, and we have two general forms for decision-making structures. As you see in this part, we can see the simple structure, and the second part, we have a dual structure. If you have just one result, which is related with a specific condition, we are applying this part. If means we want to check if what if this condition is true or not. If the result is true, so we will run this statement 1. So here's the flowchart representation for this one. You should use this diagonal shape to show this conditional structure. And we are writing this condition inside this diagonal shape, and we have true way as a result. As you see, you need to get this input, and then according to this input, we will compare something. We have a condition to check the result, and we have just two results. Our answer can be true or can be a false result. So we have no other result. You cannot add third output arrow for this diagonal shape. You should add at most two output arrows for this condition, as you see. And if the condition result answer is true, so here we are applying this process which contains statement 1. And then we are navigating our output to somewhere else. If the answer is false, we are not running another process, as you see in the simple structure. But in some cases, in the most cases, actually, we should care the other cases. What is the other cases? How can we actually, what we will run for the other cases? Yes, we have a condition, and if this condition is true, we will run the statement 1. But what about the other cases? You should care the other cases by applying this else structure. For example, if our condition is true, returns true, we are running this in a code area, and so we see the statement one declaration in here, and if it is true, we will run this one. If the answer is no, if the answer is false, if this condition is not true, so we will run this else block, as you see. So here is in this part statement 2. Let's see the difference between them. As you see, we are writing this condition again inside of this diagonal shape, and we have two ways. First one is true. In this true option, we are running this statements 1. In the second option, we else statement, the default case. So as you see, statements 2 will be run according to this false answer. So the general logic is this actually. And in the coding phase, actually, in your next classes, you will probably see this coding structures. For example, you will see Java language, you will see C, Python, C Sharp. You will see so many different languages, but the logic is the same for all of these languages. So if you want to apply this conditional structure to your coding, we have two ways generally. First one is if else, and the second one calling as switch structure, switch case structure. So we saw this one. As you see, generally we are writing this if keyword in this coding part, and we are writing this condition between these brackets, as you see, and then we have a curly bracket area. It's just a scope for this coding. If this condition is true, we will run this inner codes. And if we are carrying the other cases, so we are running this if else structure, we have to scope in this part, we have to sub area. This curly bracket divide area is related with this if area. If this condition is true, we will run this code area. If the answer is no for this condition, we will run this else code area. If you have some multiple conditions, at that case, we have a connected cases in this part. If this first case is not true, if you need to check some other cases, here is the answer. You can merge these different conditions by using this else if structures. Sorry. For example, if this first condition 1 is true, so in this case, we are running this part. If we have another condition, which is defined as condition 2, and also which is connected with condition 1, so we will check what if this condition is true or not. If the answer is true, we will run this code block. If none of them above is true, so we will run this else block at that case. In this part, nested if structure, if you want to embed any other conditional structure, you may use these nested structures. For example, I want to draw in here. Sorry, because I will check this part. Here. So we have another if structure. If this condition is true, we will run this code block. But this inner code block contains another if else structure. As you see in this part here, we have another conditional structure in here. And also this ifs else structure in here. And also we are adding another inner if else structure in this part. So we are calling this kind of structures as nested conditional structures. And also in the switch block, as you see, syntax actually totally different with this if-else syntax. So in this case, actually, we will check some different cases, but if you have some exact control points, you should use the switch case. Actually, you may check this exact comparisons in this if-else, but in most cases, um, in this kind of scenarios, we are picking the switch approach. And in here, as you see, we have another scope with the switch, as you see. And this expression will be a variable name. Actually, in this part, for example, we may write if you want to check what if this x value is greater than 10 or not. Actually, we are putting this condition into this brackets and we are writing our if at the left side. And for example, you may print something as out in that case. And if you have some else area, you may print something else. I don't know. Cannot running. Yes, you may print something different in that scenario. So we are actually checking this greater condition in here. We are checking this condition. I said before, we are checking some exact comparisons in the switch case. It means I want to check what if this x value is equal to 10 or not. Here is the exact value comparison. We are not talking about a gap. We are talking about an exact comparison. So in this scenario, how can we write in the switch expression? We are writing our variables names directly between this bracket. You don't need to write this condition in here. We are writing variable name and we have a scope area which is defined by curly brackets again. So we have a case. Case is a key word, just like our if, else, and switch. In this first case, we are writing the value of this variable, and if this x value is equal to this value, we will do something, and then we will run this break command. Break command means actually you should jump out of this switch area. And also we have a default case in here. It's so similar with the else in this scenario. If none of them is true in this scenario, we will run this default case. It's just an optional case, and it's just actually these are some beginner informations for this coding part. We will try to we won't write any code in this class, by the way. You will actually create some flow charts. In future, while you are coding, if you want to write some codes, you will initially create a flow chart. You will create a path, plan to create a better coding area. And if you want to give this plan to programming department, for example, in your future job, you should create a strong flowchart. And it means actually you should understand for coding language. How can they create this switch structure? They will pick this if else structure, or they will pick the switch case structure. And you should create a strong plan for this programming department at that case. Let's see, actually, in our previous examples, we saw some simple solutions by creating some flowcharts, as you know. And now we will use this diamond shape, as you see. We will add our decision-making scenarios by adding these diamond shapes in here. In this part, We're so familiar with these math operators, as you know, by adding operator for adding operations, we are using this minus for subtraction operations. So here, example, a plus b, a minus b, a times b. So we have a division operation in here, and if you want to apply this power operation here, you should write this one as a code to actually calculate this one. If you want to find this remainder, here is the modulation operation. And for relational operations, while we are checking our conditions, actually we are mostly using these operators. For example, what if this x value is greater this term or not? So as you see, we are using this operator in this scenario. Sorry, in this scenario we are using this greater operation. And also, if you want to check what if this x value is greater or equal to 10 or not. So it's so similar with less or less than operations in here, as you see. And for these relational operators, we are using these structures while we are expressing our conditionals in this flowcharts. We will write these conditions inside our diagonal shapes, actually. And this part for checking equality operations, actually, if you use this equal sign for one times, actually, it means it's an assignment operator. For example, if you write this one, x equals, here, because it's so hard to write it to the right side. So I used for one times, as you see, it means assign 10 to x variable. So I want to put this sign for two times. So it means I'm checking this x value, x variable's value, what if equal to 10 or not. Actually, it's a comparison declaration. It's an assignment operation. And also, if you want to check this equality operation again, but this time I want to check what if this x value is not equal to 10. So at that time, you should use this exclamation point in here. So as you know, in our first week, while we are talking about our units for our computers, we talked about ALU, arithmetic logical units. It means actually our computers, our devices can calculate some arithmetic operation results, and also we can run our logical problems in our devices. It means we have two main operation types for our computers. First one is related to arithmetic operations, and second one is related with our logical operations. For example, so and, or, for example, XOR or not. So we have some logical operations to run this kind of parts. So here we are comparing this part with, by using this relational operations, we can write this one, and also we can write this comparison. And if the answer is true from this one, if the answer is true from this one, so the AND logical result will return true for us, as you know. And here, as you know, for logical operations, true and instead of this AND word, you may use two times AND sign. True and true will return true. True and false will return false. False and true will return false, and false and false will be returned, blah, blah, blah. As you know, both of them should be true if you want to get a true result. Just like this, actually, we can use this logical operators. For example, if you want the opposite answer of this relational comparison results, you should add this not word. Instead of this, you may write this second way. And let's see some examples. Selection and control statements in here. Initially, in the simple scenario and in the second way, as you see. In this first one, we are not carrying these other cases, as you see. We are writing our x greater than 10. So it's just a condition. We will check what if this comparison's result is true or not. If the answer is yes, we will run this code line. So if the answer is no, we have no job. We have no code because it's simple usage for this if else part. Not else area in this part, as you see. We have no else keyword in this simple scenario. By the way, sorry about my voice. And let's continue with the second approach. In this part, we will check the same condition again. If the answer is yes, we will run this in a code, in this first code. If the answer is no, if the answer is false for this condition, we will run this code area. So let's create a flow chart by using the while. I will remove everything from the slides, and then I will add a screenshot. Yes, remove everything for this part. Then action size. So the initial one, I will write by using shapes. First one, first example is this one. And the second one, let's create this four charts. And first four charts, we have no reading operation, we have no, let's create a scenario. Let's read the value from user as an input. And then we will check what if this entered value is greater than 10 or not. So as you see, I randomly created a scenario. Just like this, I will give some scenario to you. Initially, before the flowchart creation, you should create your algorithms. Then you will create your flowcharts. I want to solve these questions as a faster way. Initially, while you are creating your flowcharts, while you are solving these questions, initially try to create your flowchart, algorithms and pseudocodes. Then, according to these pseudocodes, we will create our flowcharts. It must be connected with each other. And in here are the start points for this first one. And just like the let's minimize this. Stop. So I want to inform my user by printing an information message. Okay, so I will print enter, please, please enter the number. Then we will read this number, read, so the variable name will be X. Now we're done with this input operation. I want to X. And now we will check this video. So we have a condition, as you see in here. You should write your variable name in this diagonal shape. What if this X is greater than 10 or not? And then, according to this one, if the answer is yes, as you see, we will increase our Y variable by 5. Before this one, you should find X variable. Anyway, it can be still. We have a computer-based operation here. As you see, we have no interaction between our user and computer. For this reason, we used this rectangle for this process. If you have an interaction, you should use this parallelogram. And for the other case, we have no operation, and we have no printing case. And also you should write this. Yes. If the answer is yes, we will pick this way. If the answer is no, we have no other job because we are not carrying the other cases in the simple usage. Okay. And then we will apply the second one. I will update this one. In this part, as you see, we will read this number again, and also if the answer is yes, we will increase our Y variable by 5. If the answer is no, we should change this lower area. So let's remove this connection because we have a background operation. It's just a computer task, as you see. If the answer is no, we will increase our Y by 8 at this time, and then We will increase this variable by 3. And if the answer is no, we will navigate to this rectangle. And we will end our process. That's all actually is the difference for this cases. If you have actually generally as a coder, we should care these other cases. You should implement this else case. Otherwise, if you encounter with a problem, you cannot be able to solve this kind of problems because you should care each details while you are coding and also while you are constructing these algorithms in this planning part. In this part, I want to show this example. Here, let's continue. We will design an algorithm and a flowchart to find whether the given value, number, or integer is 0, positive, or a negative number. So it's in Turkish, I know. We will create our structure according to this algorithm. So I want to warn you again, while you are solving your questions in the exam, you will create this algorithm on your own before you create this flowchart. And I will pick the solution again. Picture size. Now I want to copy and paste this one here. Yes, we will read the number. Yes, we read the number. And this variable name must be number, not x. So, as I said before, these flowchart and algorithms must be connected. For example, if you give this number name for this variable, you should use this number name in this flowchart. You cannot use this another name. So first, let's raise a case number. And then we will check what if this number is greater than 0. I want to remove these structures. Here. If the answer is true, we will, according to this algorithm, we will print this number is positive. I will get this one from here, get a faster solution. Here we are printing something, as you see. I'm trying to align this one. I don't know. alignment. Yes. Hmm. In that case, we will print. Yes, it's greater than 0. Here is the condition. If the answer is no, we will check this condition. You should put another diagonal shape. Check second condition. Or if this value is less than 0. And just like this one, if the answer is not yes, we will print this number is negative. Actually, in this solution, we have a wrong logic. Actually, we have some wrong points. If this first comparison's result is true, we may print this one. Yes, we are comparing this value with 0 again for this negativity operation. And if none of them is true, actually, we have just one answer. It's it's just a 0. You don't need to check this 0 equality comparison in this third diagonal shape. And I want to change this solution by this way. If the answer is no, so the number is 0. Because we have no other option, you don't need to check. We have just 3 results. A number can be a positive, negative, or a 0. And then, if we said before, if you have another process, you should actually care input and output. We have no outputs for this part, as you see, and you should connect each one of these results with this stop area. So now we have input and outputs for each one. I'm not sure why here is the connection. And this one is a solution for this question. After the class, after the watching this record, you should solve these questions on your own. Otherwise, you won't learn. The answer is so simple. Now we will try to find the smallest value of two entered values in this part. Let's get this algorithm solution. Picture size. Yeah. Let's try to solve this question together again. I want to get this one here. Oh, I will modify this solution. So please enter two numbers. Read num1 and num2 is the variable name. Num1 and num2. Sorry, 2. And what if this one? We have actually just one condition because we have two numbers. We will check this equality operation in here. What if this number is less than or not? We will compare these numbers between each other. And in here, num1 and num2. In this solution, we will use this solution in here. As you see, they are connected with each other. And num1 less than num2. So if the answer is yes, we will print something to the output. So smallest one, I want to print as a smallest value num1. If the answer is no, we will print num2 as a smallest number at output. This output, so that's all actually for this solution. And let's create another example solution. Short one. For example, this one, you can solve this question on your own easily. We will just change the sign way. So this time, we will, in this one, we will try to find the smallest one of these two entered numbers. Now you will find the largest one. We will change this if condition. And according to this result, you will change this printing parts by changing this output message. Now, I want to find the largest of three entered numbers. Actually, we have a solution in here, and also to explain everything in a faster way, I'm not creating this pseudocodes. I'm not creating these algorithms while I'm teaching to you. Actually, I'm warning you again. You should create these steps on your own in your exams. It's an important point. I won't give you any algorithm solution to you. So for this one, let's create the solution together, step by step. I will copy and paste the solution here. So now we will read three numbers. In this scenario, and we will read lowercase num1, num2, and comma num3. Then we are comparing these numbers. If num2 greater than num3, so we will print up, sorry, for the step 3, step 1, or 3, and we will check first one with the second one, sorry, 2 here. If the answer is yes, we will check actually the second case. If the answer is no, we will jump to the step 5. I'm removing everything just like this. Actually, if the answer is yes, we will jump to another, but actually in here, why what creation of this algorithm? It's not for me actually. Probably I can create by using some other steps. But I will use this algorithm for creation. If num2, I'm writing all of these structures in here. Num3. It means actually the largest one is num2. Answer is yes. We were on this one. And then we printed this one. And what about this num3? Actually, if the answer is yes, so as we are jumping to this one, and then we are checking this comparisons results, just like this. And we have no other way implemented in this area. We will add second false options result waste arrows, and yes, we will add this one in this part. You should add 2 ways, these diagonal shapes. So if the first number is fourth one, if the answer is yes, we will print the largest one as number 1. the result. And if this result is num2, num1 is less than, sorry, and this one we will add. This means number 1 is greater than number 2. And number 3 is greater than number 1. Then we will check this one. Number 1 is the higher one. And in this case, if the answer is not true, we are checking this second number situation in here. If number 3 is higher than number 2, actually, we will print this one's result here, as you see. Yeah. And all of these printing operations must be connected with this and stop area. You may write and, you may write finish, you may write these rows instead of stop. And that's all for the solution. Skip this one. Another way, as you see, you don't need to put this three-dimension into this flow chart. It's just one of these another ways, actually. As I said before, if I want to solve this question, probably I will pick this first solution. I can imagine some other solution types for this kind of question. Just like this, you should try to create on your own solutions. As I said before, it's so similar with your fingerprint, actually. We are creating our own solutions. In the second approach, actually, we are defining another variable as big. So we assign this first variable's value as a maximum number into this big variable. If the second one is bigger than or greater than big, so we can say the maximum value is this second one. And if the third one is greater than this one, we are assigning the c's value, third value, to this big variable, and then we can print this maximum highest value at the output. And probably I can pick this kind of solution while I'm solving this algorithm. And I will show this solution to you. And here's the scenario. You will design the algorithm and flowchart that finds whether the student passed the course based on the midterm and final grades entered. Actually, while we are calculating this average um, um, passing grades, we are using this equation in here. And in this part, probably if I will ask this kind of question to you, I will give this equation to you. And also I will give this kind of boundary value to you. You don't need to give these random values to your scenarios, and it's so general explanation. It's just an example. And in this kind of part, actually, we are starting the solution. We are printing our information message to our user, and we are reading midterm grade as a first entered value. Then we are reading this final grade as a second entered value. And this midterm is a variable name. This final is a variable name. So we are using this variable names while we are using actually applying this equation to find this average value. If this average value is greater or equal to 60, we will print the student test. Or else, actually, in other cases, it must be less than 60. For example, it can be 59. At that case, you will print this failed print of text at output. So here is the solution. In here, we are starting and stopping this whole part in here. We are reading midterm and final. So it's in Turkish, but I will explain. I won't draw again and again and again. I think you possibly understood how can you create your flow charts by using this Drawwire or something else. By using pen and paper, you can easily create this kind of diagrams easily by using the same logic. And I will just explain what is this solution. And here we have no information message initially. The first failed actually. You before this reading operation, you should print this information message to your user. Enter a midterm grade, then you will read midterm. Enter a final grade, and then you will read this final. After these writing and reading operations, we are calculating this average value by using this entered midterm and final grades. So I will check what if this average grade is greater than or equal to 60. If the answer is yes, we will print this past. It's a special shape for this printing results at the output. Instead of this shape, you may use this parallelogram again, just like my solutions. We are printing this past message at the output. If the answer is no, we will print this failed message at the output. That's all. So in this example, actually, we will try to create the first and Fibonacci terms, just like this one. For example, initially you should know what is Fibonacci now. Here, as you see, let's. I want to show this Fibonacci series. Yeah. So as you see, we have some terms, and third one will be equal to numbers, previous two numbers, summation value. As you see, 1 plus 1 equals 2. In here, as you see, 3 equals to 2 plus 1. And we are carrying previous two numbers, as you see. For example, 5 equals 3 plus 2. 8 equals 5 plus 3, 13 equals 8 plus 5, blah, blah, blah. Actually, in this question, in our question, our user will enter a number which is defined as n is the total amount of these numbers. So for example, I want to print first n numbers from this Fibonacci series. For example, if the user enters 5 or 6, I will print first six Fibonacci numbers at the output. The question says this. Initially, you will try to solve these logical steps on your own. Here is the solution, as you see. I'm sorry, this one is the solution. Actually, you should care. We'll take this chart in here. These are the numbers. And also, as a first number in this question, we are printing 0 in here, as you see. So initially, we will read a number in this part. We will generate first and Fibonacci terms in this question. So it's just a counter. We need to count. We need to define a counter which will be equal to n or not. At that point, actually, we will stop. And in here, as you see, input value will be n, uppercase N. A will be 0. It means actually we have a 0 value at the left side. So 0 in this part, according to this logic. And A will represent our first number initially, its first initial case. And B will be the second number. And count. Actually, our count should be starting with 2 because now we are done with this first 2 of the series. Now we have 2 numbers and we are printing our A and B in this order and our count is 2 now because we are done with this first 2 of them. Then if the count is greater than n, so we will calculate the next one. Sorry. We will calculate the next one. Next is another variable in this part. I'm just explaining this logic. So it will be the sum of these previous 2 numbers, so it will be 1, right? Then we will write next the right side of these 2 numbers. After this printing part, we will update our A, B, and count variables for the step 8, 9, and 10, as you see. So now our A will be this one, our B will be this one, our next will be this one, and by this way we will calculate the other numbers. So according to the situations, actually we have just one condition in the scenario, as you see, and other parts is so related with this calculation part. And in this part, actually, I will stop at that point. We try to understand this question's solution on your own. If you have another question, you can ask at the class time. But in this part, as you see now, we will check what is an answer to value, which is defined as non-variable, is a prime number or not. Actually, we construct that this structure is an algorithm for the solution, and we are showing this flow chart at the right side. Actually, that's all for this class. If you have any question, you may ask. Okay, see you at the class. Bye.